Okay, so, right. So I'm going to be taking a look at the final exam for spring 2017. Okay. This is going to be question 8. And we're looking here, we want to find the third degree. They call it a Taylor polynomial, but we're centering at 0, which is really a Maclauren polynomial, right, for our function. And the function that we're given is f of x equals the natural log of 1 plus x. Okay. So we're centering it at x equals 0, and our function is natural log of 1 plus x. Okay, so let's remember what our Maclauren is going to look like. Okay. So our Maclauren polynomial is going to look like, I'm going to drop the 0 here. I'm going to take my function, evaluate at 0. Take my first derivative, evaluate at 0, it's going to be x to the first power. Plus my second derivative, evaluate at 0, x squared all over 2 factorial. Plus my third derivative, evaluated at 0, times x cubed all over 3 factorial. Okay. So these are the coefficients. So these are the coefficients, right, that I'm going to be solving for, right, when I go to figure out what my derivatives are. Okay, so let's do our table. So my function, and then my x is equal to a, which in this case is equal to 0. Okay. So my function itself is equal to the natural log of 1 plus x. When I evaluate my function at 0, I get the natural log of 1. The natural log of 1 is equal to 0. This is my first coefficient. It's going to go into that spot right there. My first derivative, okay, is going to give me, okay, watch out what's going to happen. I'm going to take this 1 over that. And then the chain rule says take the derivative of what's inside. Now what's inside is just x. When I take the derivative of x, I just get 1 times dx. This is just going to be times 1. So I don't have to worry about like accumulating negatives like we do sometimes, like if this was 1 minus x, for example. Okay, so f prime evaluated at 0, which is 1 over 1, which is just going to give me 1. My second derivative, okay, so let's write this out as 1 plus x to the minus 1. Okay. So now, right, when I want to take my second derivative, I've got my exponent, multiply out front. I got 1 plus x. I have to subtract 1 from my exponent, so I get minus 2. So my second derivative, evaluated at 0, is minus 1 times 1 plus 0 raised to the second power. All in the denominator, so it just becomes minus 1. My third derivative, okay, which is going to be my exponent, minus 2 times minus 1, 1 plus x, and I'm going to subtract 1 from what's there. You know, I don't have to worry about my chain rule because it's just going to be equal to 1. My third derivative, evaluated at 0, is just going to be minus 2 times minus 1 times 1 over 1 plus 0 to the third power is just positive 2. We know in this they're going to ask us for our error calculation, so let's go ahead and calculate out our fourth derivative, okay, because they want the error calculations for the third order. I need my fourth derivative for that. Okay, so my fourth derivative is going to be minus 3 times minus 2 times minus 1, 1 plus x to the minus 4. I'm going to write this all out. So this is minus 6 times 1 plus x to the fourth power. This is my fourth derivative. Okay, we're going to need to calculate our z value, but we're going to use this later in our error calculation. All of these numbers here are going to go into part A's answer, which is going to give us the coefficients for our Maclauren. Okay, so let's go ahead and plug those in because part A says, give me the Maclauren. Okay, so f0, 0, plus the first derivative, evaluate 0 is 1 times x, plus the second derivative is minus 1 times x squared over 2 factorial, plus the third derivative is 2 x cubed over 3 factorial. Now I can multiply things through, make this look a little nicer, get rid of the 0. So it's going to be x minus x squared over 2, 2 factorial is 2, plus 2 over 3 factorial, this is 3 times 2, cubed over 3. And so this becomes our third order Maclauren for the function ln of 1 plus x. Okay, so that's what we needed to calculate. Okay, so now part B says, come up with an error. Okay, so we need to find an upper bound on the error, and we're doing a third degree error calculation. And we're going to be taking a look at x's around like a 0.2 window around where we're centered. And we're centered at x equals 0 because it's a Maclauren polynomial. Okay, so that means let's come up with our formula for our error. It's going to be the max of the n plus first derivative, so that's the fourth derivative, evaluated at some value, we'll call it z, times absolute value of x raised to the n plus 1 all over n plus 1 factorial. Okay, this part here we need to do some legwork to figure out what we're going to do for that. So let's think about this one. Max to the fourth of z. So I need to calculate that. Okay, so for that I'm going to go back to the boundary that they set to me. Okay, so for this here I'm going to say minus 0.2 is less than or equal to x, which is less than or equal to 0.2. Okay. Now when I look at my derivative, the derivatives that we calculated, remember we said we needed our fourth derivative. We were looking at minus 6 all over 1 plus x to the fourth power. Now when I look at 1 plus x to the fourth power, I'm not quite sure what's happening, right? So I graphed it out. So my calculator, I did, in this case, I did 2, but I can just do even just a 1. 1 plus x to the fourth power, and I go to graph it. And this is what I get, right? So when I'm looking right around 0, which is where we're centered, I have a decreasing function. So my derivative is a decreasing function. Now when I'm dealing with a decreasing function, right, our derivative is a decreasing function. So I'm going to choose the lower bound on here in order to plug it into, I want my z equal to minus 0.2, okay? Because that's going to maximize my derivative, right? If it was an increasing function, I would choose the upper bound in order to maximize. Okay, so let's plug in what we have here. So this is going to be max of the absolute value of minus 6 all over 1 plus, I'm going to call it z to the fourth power times x to the fourth factorial. Okay, now here we just chose z equals to minus 0.2, so I'm going to plug that z value into here. So this is going to be max, which I can get rid of the max because I just, in choosing that z value, I'm maximizing it. So that's equal to the absolute value of minus 6 over 1 minus 0.2 to the fourth. This is plus a negative 0.2 times x to the fourth over 4 factorial. Okay, so now what do I choose for this x line? Well, they gave that to me right here. The absolute value of x is less than or equal to 0.2. So this 0.2 I'm going to plug in right there. So this is equal to, I can get rid of the negative in the absolute value, because this becomes 6 all over 1 minus 0.2, 0.8 to the fourth power, times 0.2 to the fourth power, right? I'm plugging in the 0.2 that they gave me over 4 factorial. Okay, now all these numbers, right, I can just plug into my calculator and come up with the value. And when I come up with the value on this, I'm going to get roughly 0.1231765, okay, as my error calculation. This is a reasonable upper bound. I can show the whole thing. A reasonable upper bound on my error calculation for third order Maclauren. Okay, third order Maclauren means when I calculate the error, I look at the next term up. Okay, this part here requires some legwork, okay, where I have to take a look at what's going on with my derivative. My derivative around this interval here, right around where I'm centered, okay, this is like, you know, I'm centered around 0. My derivative is a decreasing function, which means I need to choose the lower end of that in order to maximize. This is my z value. I plugged it in for right there. 1 plus a minus 0.2 gives me 1 minus 0.2, which is 0.8 to the fourth